All right, so yesterday we finished up going over all of the possible formulas for acceleration that are on your formula sheet. We looked at how all of them get manipulated. Okay, we reviewed that acceleration is a change in velocity over time and is measured in meters per second, which we abbreviate meters per second squared. Okay, so now comes the challenge. I give you a question and I don't tell you which formula you should use for it. You've got to figure it out and then manipulate and solve. So on the board are two questions that I am not telling you which formula to use for. Okay? And you can figure it out. Remember that all of your units need to match. If you're given time in seconds and something else in meters and something else in kilometers, you need to make sure that the units all match. So, especially on question 2 there, where you're given the velocities in meters, or sorry, in kilometers per hour, okay, and everything else in meters per second, you should probably make them match. Okay? So I'll give you a little bit of time on those, and then we'll go through them together. Okay, so in number 1, okay, our givens are that the jetliner lands on a runway at 70 meters per second and then reverses its engines to provide braking and comes to a halt 29 seconds later. Okay, so from the context of that question, okay, so I would know the initial velocity, 70 meters per second. That's kind of how this question starts from the context. Okay, they tell me that it brakes or decelerates or negatively accelerates for 29 seconds, okay? And they also tell me it comes to a halt. What else did they give me without giving me a number?
Velocity final is equal to 0.
Right, velocity final is equal to 0. Again, it's just some of those little contextual clues that we have to get from the question. All right, so I know VI, I know T, and I know VF, and part A wants me to find the acceleration of the aircraft. Do I have a formula that has those 4 things in it? It's the one from last year, from Science 10, okay? That acceleration is a change in velocity divided by a change in time. I've got all those numbers, 0 minus 29, minus 70, sorry. Time is 29, minus 70 divided by 29 seconds. Okay, so if we punch that into our calculator, we should get, it should come out to negative 2.4 meters per second squared. Now, on that question, they didn't ever really give a vector. Okay, we would assume that a plane lands while flying forwards, because I've never seen one land while flying backwards. Okay, the wings don't really work that way, and that whole shape and providing lift. Okay, so we would assume it's going forward, but because they didn't say that, I could leave my answer as negative 2.4 meters per second squared. That would be fine. Okay, just so you know, please never do what they've done here. Okay, never write negative forward. That's like saying negative north is south. Nobody says that. Okay? Nobody says, I live 2 kilometers negative west of here. I mean, that means east, but only in a world where people say things backwards. Okay? We're not doing that here. Don't say negative forward, say backward. That would be fine too. Instead of negative 2.4, you could say backwards. Okay? Or in the opposite direction of movement, or something like that. Okay? But please don't ever say negative forward. Okay? That's negative yesterday is tomorrow. Like, it's just dumb. We don't speak like that, so we shouldn't write answers like that. Okay? All right, the second part of that question wants to know, now that we know acceleration, how long the runway has to be. That would be the displacement of the plane while coming to a halt. Okay? Do I have a lot of choices at this point for which of the other acceleration formulas I can use? I do. What formula can I absolutely not use for this? This one. I get people who try to use that formula in an acceleration question. What does that formula apply to? It assumes V is constant. Okay, that formula only works when v is constant. You cannot use it, okay, for an accelerating object. So I could use this one. Okay, I've got all the information for that one. I could use the VF squared equals VI squared plus 2AD. I've got all of that information as well. You have a choice here. You could use any of the other formulas that we've gone over for acceleration, and they'll all give you the same answer. Okay, since I've got this and I now have A, I'm just going to plug this one in and go 70 times 29 plus 1/2 times negative, sorry, it's supposed to be times negative 2.4 times 29 squared. Okay, so I punch all that in. Okay, 70 times 29 plus 0.5 times negative 2.4 times 29 squared. Okay, so that runway's got to be close to, oh, hang on, I made an entry error there. Oh, that seemed like kind of a long number. 2.4, that's better. Okay, so I'm going to need a runway that's just over 1 kilometer long for this plane to land. Okay, everybody all right with that one? Okay, how many people have done number 2? Okay, I'm going to give you a couple more minutes on number 2. Sorry. Okay, good. Okay, give you guys a couple more minutes on number 2, and then we'll look at that one. Okay, so on-ramps. So when you come onto a highway, like the one out here, okay? On-ramps are designed so that motorists can move seamlessly into highway traffic. That's what they're for. You've got to use them right, though. Okay? This is my rant for the day. Okay? When you are merging into traffic, you must depress the pedal on the right. Okay? And you've got to push it down really hard so that you go fast in that on-ramp. God, I can't stand it when the person in front of me is like, doo, 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 and they're just go, okay, press that pedal and get up to highway speed. Okay? You guys ever been behind that person? Okay? And they're like still coming off the exit ramp, and there's people whizzing by you at 120 and they're going 65 and they just won't speed up, and they're going to cause an accident. Okay, don't be that person. On-ramps are designed to get you up to highway speed. But good life lesson. Okay? Then you won't be the person who looks in their rearview mirror and sees my grill. Okay, right in there. Because that's me. Okay, if you're not going fast enough, I'm going to be right there. Okay, all right. Rant over. So we want to go from 50 kilometers an hour, which we have to convert to meters per second. Next, so 50 divided by 3.6. All right, it's going to give us 13.8 repeating meters per second. Okay, and we want to get to 100 kilometers an hour, which would be twice that number. But just so that we've got it in the calculator, we'll do that. 27.7 repeating meters per second. Okay, and the engine can provide a maximum acceleration of 3.8 meters per second squared when the pedal on the right is depressed fully. Pedal on the right makes it go. Okay, so we've got those three numbers, and we are looking for the minimum length of the on-ramp. In other words, the distance the car will travel while accelerating. Okay, what formula should I use with those givens? Which formula, guys?
The VF squared equals VI squared plus 2A.
Exactly, this one. Okay, could I do this another way? Yes. I could probably do this in 2 steps by using another formula to find time and then using another formula that has time in it, but I'm a busy man, okay? And I like to do things quickly and in 1 step. This will solve it in 1 step. On an exam, do you want to do this as quickly as possible? Yeah, okay? I mean, if you do it the long way and you get the right answer, you're still going to get full marks. but you did it the long way and it's gonna take you longer. Okay, so you wanna be as efficient as possible. Find a formula, if possible, that will do the question in one step. Okay, so we're looking for D. We've got to manipulate this for that. So the first thing I want to move is VI over to this side. So I'll have VF squared minus VI squared equals 2 times A times D. I want to get D by itself, so I will then divide both sides by 2A. All right, so now I've got my fully manipulated formula. All I have to do is plug in my numbers. All right, so that's going to be the 27.7 squared minus the 13.8 squared, okay, divided by 2 times 3.8. What do you suppose people forget to do in this formula most often? Square those numbers. Yeah, okay, that's what usually, if there's a mistake that somebody makes after having done basically everything else right, it's entering the squares in their calculator. All right, so our total distance here, if we plug that into our calculator, of course, keeping all of our decimals from before, okay, we would have this number squared minus that number squared, and then we would divide that by 2 times 3.8. And we're gonna get 76.1, but we only have 2 significant digits, so they would need 76 meters to achieve that acceleration. Okay, everybody all right with that? Is there some algebra here? There's a bit of algebra here, okay? Now, what we're gonna be moving on to once we've kind of mastered the acceleration formulas is combining acceleration and vectors into projectile motion. Okay, so anything being, anything flying through the air in the influence of Earth's gravity is a projectile. Anything in unpowered flight. So a rock that you throw, or a ball that you throw, okay? Or an arrow that you shoot from a bow, anything like that is a projectile. Okay? And they all accelerate due to gravity. And that's what we'll be looking at next week. All right. Okay, this one's got some contextual tricks in it, okay? So I want you to give that one a try. I'll give you about 3-4 minutes here and then we'll look at it. Does it seem like this one doesn't give me very much information? It does, right? Like when you read it, there's only one number in that question and it's a displacement, 6 meters. Okay, but this is where I have to do that thing we talked about the other day. I've got to visualize this situation. Okay, so if I've got a bolt, anything for that matter, okay, and it's on top of a building and it just falls off, what was its initial velocity?
Well, when it started falling,
0. Okay, I didn't throw it downwards or throw it upwards. It just fell. Okay, if it just falls or it's dropped, it doesn't have an initial velocity. Okay? As soon as the acceleration starts, it's going to pick up speed, but at time 0, the velocity was also 0. So if something falls off or is dropped, those are contextual clues that its initial velocity is 0. Okay? If the initial velocity isn't 0, then there'll be some mention of it being thrown or projected or shot. Okay? That will tell you it was actually moving at time 0. So if something just falls, its initial velocity is 0 meters per second. Now, the falls also tells me something else. What?
its acceleration is 9.81 meters per second.
Right, things fall because of gravity. Okay, so I've got those 2 extra pieces of information. Okay, now, they want me to find out how long it's going to fall for. So I've got 3 pieces of information, 3 givens, that's it. Okay, and I need to find time. So what formula has these 4 things in it? Which formula do I want to use here, guys? Okay.
D equals VIT plus 1/2 AT squared.
You know, that one I told you you'd never have to use to solve for time, that formula? Except I said, you'll never have to use it to solve for time if VI isn't 0. Is VI 0 in this case? All right, so now I can use this one. Because since VI is 0, VI times T is 0. So I can just get rid of it. Right? Now I can say that D equals 1/2 AT squared. So I can solve for T pretty easily by dividing both sides by half of A, and then square rooting. Right? Now I'm solving for T. Okay? So T will equal the square root of 6 meters divided by 1/2 times 9.81. I'm going to make both of those positive. They're both down. The thing doesn't change direction, so I'm just going to make down positive. Okay? And plug in my numbers. Okay, so that thing is going to take 1.1 seconds before it hits the ground. Okay, is that a tricky question? It is. Okay, it's another one of those contextually difficult. Once we got to the math, was the math in? I mean, it was just algebra, right? It was a tricky manipulation maybe, right? But what makes that question difficult is being able to glean all the information from it that you need. Okay, so again, like I said before, it's visualize the situation. And if you can picture it in your head, sometimes some of the other stuff will come out. Right? Okay. Try that one. Okay? This is kind of a slingshot kind of question. Okay, a lot of people in this question will assume that because the object hits the ground, that VF is 0. But when the object strikes the ground, the instant it strikes the ground, VF is at its maximum. That's where it's going the fastest. We don't know what that number is. VF is 0 after the object slows down and stops. It's actually a separate acceleration to stop the object. Okay, so something striking the ground is not meaning that VF is 0, unless you're told it hits the ground at this speed and takes this long for it to stop. That would be the second part of that question. Okay? So we can't assume in a question like this that VF is 0 because it isn't. We can assume VI is 0, but not VF. Okay? All right. Okay, back to that one. All right, so on this question here, we're asked for the final velocity. Okay, so VF is our unknown. Okay, of a rock that is propelled over a 0.30 meter distance, okay, by an acceleration of 22 meters per second squared, okay, for a 0.72 second interval. Okay, now they don't tell me VI here, do they? And I can't necessarily assume it's 0. I mean, the context of the question, when you got something in a slingshot, it's probably not moving initially. But in the end, I don't even need it. All right? I've got enough information here to find VF because I have a formula that has all of these things in it. And that is D equals VF times T minus 1/2 AT squared. Okay, I can use that formula in one step, not have to make any assumptions about what the value of other things are, okay, and go towards a solution. So what I'm going to do is add 1/2 AT squared to both sides. Okay, and then that'll equal VF times T, and then I'll simply divide both sides by T to get VF. All right, then I'll plug in my numbers. So that'll be 0.30 meters plus 1/2 times 22 times 0.72 .72 squared divided by 0.72. Okay, so we'd be looking at a final speed, because they didn't actually give me any directions here, okay, of 8.3 meters per second. Okay, if I was gonna put a velocity on that, I guess I would say positive. Okay. All right, questions on that one? Okay, usually guys, the thing that proves the hardest for people is actually finding what formula to use, okay, and effectively doing it in one step. I know you guys can handle the algebra. You wouldn't be in physics 20 if you couldn't do algebra, okay? So that's the trickiest part. Okay, try this one. All right, so for this one here, we're looking for VI. We want the initial velocity on this one, okay, of a bullet that enters ballistics gel. Okay, if you've ever seen, like, they used to do this in Mythbusters all the time, but they would, either, project things or shoot things at this dummy that was basically it made it look like it was made out of Jello, but it's ballistics gel. It has the same consistency as the human body. Okay? So what they can do with that is they can tell from how far the bullet penetrates or how quickly it exits, if it goes through, okay, approximately how far away the person was shot from. Okay? It's an important piece of investigative material, okay, that police would use. Right? So the bullet enters the ballistics gel and slows at an acceleration of 150 meters per second squared. What do I need to remember about it if it's slowing? It's negative. Okay, that's the trick in this question, the contextual thing you need to get from it. All right, for 0.252 seconds, okay, if its final velocity is 65.2 meters per second. Okay, so that would be forward. Okay, that means it probably exits the ballistics gel. Okay. We're looking for VI. Do I have a formula that has those four things in it? Okay, for a good old science 10 formula. Okay, so we've got to manipulate it for VI, which is probably the trickiest manipulation of that formula. Okay, so I'm going to multiply both sides by t. Then I'm going to add VI to both sides so that it becomes positive. And then I'm going to subtract t times a over. So I'm going to have VI equals VF minus t times a. So that'll be 65.2 minus 0.252 times negative 150 meters per second squared. Now, here's the thing, guys. If you do this wrong, your answer won't make sense mathematically. Okay, so it's kind of a way for you to check it. If you forget to make that 150 negative, I think you end up getting that the bullet was moving backwards initially. Okay, and that can't possibly be right. So it's a way you can check. Look at your answer, and within the context of that question, if your answer doesn't make sense, you probably did something wrong, but it's probably something simple, like forgetting a negative, right? So on this one here, we're gonna have 65.2 minus 0.252 times negative 150. All right, that's a slow bullet, okay? It's 103 meters per second, okay? It's pretty slow, but that's what we got. Okay, everybody all right with that? All right, don't pack up, we have one more for you. Maybe not, there's not enough time. Okay, good work today, guys. Monday, I'll probably throw some tougher ones at you, and we'll start looking at the pre-lab stuff for our acceleration lab.